In this video, we will first review the use case of our current simple RBAC system in the application. Next, we will discuss some of the limitations of this approach. As the application grows and access requirements become more complex, managing permissions through roles alone can become more difficult and less scalable. To solve these challenges, we will introduce a permission-based RBAC system. We will see how permissions can provide more granular control over application actions while keeping authorization easier to manage. Finally, we will implement this system in our application by defining permissions, mapping them to roles, and enforcing them on protected routes. To make it easier to follow along, I have created a separate branch in the GitHub repository that contains the implementation shown in this video. You can switch to that branch or clone it directly to explore the code and interact with the new permission-based RBAC system yourself. I will provide the repository link and branch details in the video description. Simple RBAC system is most effective when an application has only a small number of user types. Each role has clearly defined responsibilities and permissions do not change very often. This is commonly the case in small applications or internal systems. For example, consider a personal blog CMS. We might have three roles: admin, author, and reader. The admin has full access to the system and can manage all the content and users. The author can create and edit their own blog post. The reader has the most limited access and can only view published posts. In this type of applications, the access requirements are straightforward, making role-based authorization simple to implement and easy to maintain. But there are some problems with this simple RBAC system. Scalability issues as more roles are added. Currently, our system has only two roles. Admin has access to all the operations and student has limited access to certain routes. With only two roles, authorization is simple and easy to manage. But suppose we introduce a new role called instructor. An instructor should be able to view enrollment records, view all the users and courses records, but should not be able to delete enrollments, manage users, and change system settings. For now, in our system, all of these functionalities are restricted to admin role users only. This means when a new instructor role added, it has some access to admin level route, but not all of them. So how can we implement it? This is a route for accessing all the enrollment record. For now, this is only accessible by admin role users only. But we want this route to allow to access by both instructor and admin. Since instructor should be able to view enrollments, we need to update the authorization logic. So how can we do that? We have to create another middleware function with name instructor-admin. This middleware checks if the user have any of these roles of admin or instructor. If any other role of user try to access the API endpoint, then deny the access. At first this seems reasonable, however problems start appearing as the application grows. Now imagine the system has several roles: admin, instructor, student, teaching assistant, department manager, content creator, or auditor. Different routes may require different combination of roles. For example, look at this middleware by the name is admin or instructor or manager. As new roles are introduced, the number of roles combinations grow. As new roles are introduced, the number of roles combinations grow rapidly. You may find yourself creating dozens of authorization middleware functions. We have to create authorization logic for every route and every operation in the system. This often leads to long role checking conditions if-else statements to determine which users are allowed to perform a specific action. The same role checks are repeated throughout the application. When a new role is added, existing routes and authorization logic must need to be modified all over the system. This may also lead to higher risk of authorization bugs. Developers may forget to update existing route when a new role is introduced. This leads to duplicate logic, increased maintenance effort, and poor scalability. This problem is commonly known as role explosion, where the number of roles and role combinations grow faster than the system can easily manage. To solve this problem, we need more flexible approach, and that's where the permission-based RBAC system comes in. In a permission-based RBAC system, we start by identifying the actions user can perform in the application and defining permissions that can control access to those actions. These permissions are then assigned to different roles based on the responsibilities and access requirement for each role. Let's understand it with the example. In our demo application, there are several actions that users can perform, like users may be able to view their profile, update their profile, delete courses, view all the enrollment records, or create a new record. Each of these actions is typically handled by a specific API endpoint or route in our application. But now in our system, we need a way to define which type of users can perform each action. For example, we may want to restrict students from viewing all the enrollment records, while allowing both admin and instructor users to access that action through corresponding route. Instead of performing role check on every route, which we have already seen can become difficult to maintain and scale, we create a permission for each action in the application and use those permissions to control access. For example, let's look at the API endpoint for viewing all the enrollment records in the system. Rather than checking whether the user has an admin or instructor role, we define a required permission for this action, enrollment read all. When a request reaches this endpoint, we simply check whether the user has this permission. If they do, access is granted. Otherwise, the request is denied. After creating a permission, we need to assign this permission to the roles that actually needs it. In this example, we assign both the admin and instructor role users with enrollment read all permission, while the student role does not have this. As a result, admin and instructor users can access the route, and student users are automatically denied the access. Notice that the route itself does not need to know anything about the roles. It only checks for the required permission, making the authorization logic more flexible and easier to maintain. So why this approach is better? Now imagine that later we want to introduce a new role called auditor. Auditors should be able to view all the enrollment records just like admin and instructor. With our previous role-based approach, we will likely need to revisit existing routes and update authorization middlewares to include this new role. This means updating multiple routes throughout the application. With our new permission-based RBAC system, this process is much simpler. Since the route already requires the enrollment read all permission, all we need to do is assign that permission to the auditor role. No route changes are required, no middleware needed to be modified. The existing authorization logic continue to work exactly as before. Now let's see how can we implement this permission-based RBAC system in our application. To implement permission-based RBAC system, we typically follow three steps. First, we define the roles that exist in our system like admin or student. These roles represents all the different type of users in the system. At this stage, roles do not have any permissions yet. We are simply defining the user category that exists in our application in a separate file. The second step is creating a permission for every action. We define permissions that represent the actions user can perform in the application. These permissions are typically associated with a specific API endpoint or operation. For example, a user profile manager may support several actions, and each action can have its own permission. We define a separate permission for viewing a profile, updating a profile, and deleting a profile. By creating permission at the action level, we gain fine-grained control over what users are allowed to do within the application. A good practice is to keep all the permissions in a single file, so they can be managed from one place. Notice that the permission describe what a user can do, not who is the user. These permissions can then be used to protect routes throughout the application. This approach gives us a centralized list of all the available actions in the system. After defining roles and permissions, we need to connect them together. This mapping determines what each role is allowed to do. Now we have a clear relationship between roles and permissions. Now you can clearly see which action an admin can perform and which action a student can perform. If you need to add or if you need to add or remove permissions from a role or introduce a completely new role, the process becomes much easier to manage. You simply update the role permission mapping without modifying authorization logic across multiple routes and middleware functions. This makes the system easier to understand, easier to maintain, and much more scalable as the application grows. Going forward, whenever you need to create a new API endpoint or introduce a new action in the application, you simply define a corresponding permission for that action. You can then assign that permission to whichever roles of user should be allowed to access it. As a result, authorization becomes much more centralized and predictable. Instead of updating route-specific role checks throughout the application, you only need to manage permissions and their role assignments. So why this design is better? Permission-based RBAC system provides several advantages over a simple role-based approach. First, it helps us eliminate role explosion. Instead of creating more and more roles combinations as requirements change, we can simply assign permissions to the appropriate roles. It is also much more scalable. As the application grows and new roles are introduced, we do not need to rewrite authorization logic across multiple routes. Another major benefit is centralized access control. Permissions are defined once and then reused throughout the application, making the system easier to understand and maintain. Since we are checking the permission in the API endpoint instead of for specific roles, adding new roles in the system become much more simpler. We can often support new business requirements by updating permission assignments instead of modifying application code. In the upcoming videos, we will explore how permission-based RBAC improves security of our system by enforcing more granular access control and helping implementing security principles such as least privileges and deny by default. If you want to stay updated with the authorization security for developers series, make sure to subscribe to this channel so you do not miss the upcoming videos.